Welcome to Reliability Matters, a podcast for the electronic assembly industry. Each episode covers topics related to reliability, best practices, and environmentally responsible assembly techniques, with insights from experts across the electronic assembly industry. Now, here's your host, Mike Conrad.
Welcome back to another episode of the Reliability Matters podcast. I'm Mike Conrad. I am not in my normal studio. I am in Anaheim, California at the IPC Apex Expo. And a big shout out to Trevor Galbraith for allowing me to interlope in his studio here at the show in his booth, and to the technical wizards, Summer and Jen. You can't see them, but they're there, and they're the ones pushing the buttons at all the right time. So they're the ones that make us appear the best we possibly can, and that bar is usually pretty low. But you guys are doing great. Thank you. My guest for this short episode is David Chiu. David Chiu is the sales manager for Test Research. Welcome, David.
Hey, thank you, Mike. Nice to see you.
Being my guest. Yeah,
no
I appreciate
problem.
it.
Thank you.
So as my audience is well aware, this is the Reliability Matters show.
Okay.
So we're going to talk about your product, and then we're going to weave your product into reliability.
Okay.
How a product like yours will impact reliability, hopefully for the better. Right?
Sure.
So what we're going to talk about is AOI inspection systems, and you have a machine here at the show, which
Yes.
you call your TR7700 QHS2.
Yes.
So clearly whoever named it got a bonus if they could use almost every letter of the alphabet. I mean, it's a long name for a machine. And it's a 3D AOI
Yes,
system.
it's
AOI,
3D.
of course, for the majority of my audience, we knows this, but for those who are wondering, what is AOI? Automated Optical
inspection machine. Yeah.
So what are the differences between a 2D AOI system and a 3D AOI system? I think we all know what 2D and 3D is, but how does that land on a technology like yours and products like yours?
Okay. Remember when I was an engineer before, we only have 2D machine, 2D AOI. But for 2D AOI, you only can see it from the top. So everything you can see is from the top, so you cannot see the height.
Right.
So you only can see the marking and the shifting and the skew. That's it. So for sometimes, if you have the lift lead or you have the bad solder joint, it's not very easy to see it.
Right.
So when you involve with the 3D technology, then you can see how tall is the pin lead and how is the solder volume looks like. So you can get rid of those issues, so you don't need to worry about, I cannot see it very well from the 2D. So
Right.
3D is really help.
Are most of the decisions that result from an image of a board on a screen
Yes.
coming from an operator looking at the picture and going, oh, that's not right? Or do you have AI or any other type of automated, go, no go, pass, fail, this is wrong. Does it flag errors that it sees, or is it relying on an operator to interpret it, or both?
Right now you're talking about the new technology we call AI. So before we more rely on the quality guy. So they use human eyes, they use human judge. Right. So sometimes if they don't pay attention on the pictures, they will miss. Okay, but right now we have AI, so we involve with the AI repair station. So we let the system to judge, but system need to learn. So in the beginning, it's just like the child, like the baby. When the system got more and more information, we call big data. Then they got the big data to go fit into the system. So system can judge it automatically. So it will become better and better.
And what are the typical types of defects your machine, that your users, your customers are using the machine to detect?
So most of the time we use the 3D AOI to check the component height and pin height and the solder volume. So that is the most important thing to check it by 3D.
And I would assume, specifically for 3D.
Yeah.
In terms of AOI systems in general, I'm thinking polarity is one, missing components is
if you are talking about just the AOI, most of the customer, they use AOI to check the polarity and the shifting and the missing.
Right.
Yeah, that is a very typical fail. You have to check by AOI.
Can they be programmed to determine if the right component is used?
Yes, we can check it by the marking or the color, and the size. So you can use those specific data to find out if that is the correct parts you are using.
I've read in some journals recently that AOI systems, probably pretty advanced AOI systems, can also be used for counterfeit detection. Using an ever-growing library and artificial intelligence, it can spot a known good part, a verified part from an unverified part.
Yeah.
You know, maybe subtle differences in the markings and things like that. Has that landed in your world at this point yet, or is your world more of the proper components and the proper orientation in the proper place?
We are still using the proper component for it. So you still need the correct part to compare with the current part. So you have to use those as the template to check it. So, but we are getting more and more data from different vendors. So if you get all the data correctly, our AI can use those data to verify by itself.
Right.
Yes.
And typically your machines are used after reflow, or do you do any SPI as well, like before reflow?
For AOI, we do pre-reflow and also the post-reflow for both. For pre-reflow, you are not really focused on the 3D, so we just use that one to check the
just to make sure the right components are
the right
placed.
component is on the correct location. That's all.
Yeah. Even polarity at that point.
Yes.
Yeah.
After the oven, you have to check if something happened after the oven, like you need to check the solder joint. So after oven, you have to more focus on the solder joint.
Yeah. And you started answering this, but just to make sure I have the full answer, what can 3D AOI inspection systems do that 2D cannot do? You talked about scene height.
Yeah.
What other types of defects are unique in terms of discovering the defect, are unique to 3D machines versus just 2D machines?
Yeah. Except the component height, you also can measure the pin height, literally. Also, you can measure the volume for the solder joint, because sometimes according to IPC standard, if you have solder joint, it doesn't mean you have the good solder joint. You have to get enough height and enough volume to determine that is a good solder joint. So that is the one 2D machine you cannot do.
And last question, what advice would you give to a person in our industry that's looking for an AOI machine? What questions should they ask potential suppliers? If you were a buyer of machines and you didn't know TRI, what would you be looking for in terms of vetting and evaluating a company and its products?
It's only for 3D?
Any AOI.
Any AOI?
In general.
Okay, so if I'm the customer, I will go ask what resolution you have, because it depends on what components I have.
So that's a megapixel question? Or it's a different...
First thing I will ask what resolution you have. So higher resolution, you can get the better image for the small component, but it will increase the cycle time because the scanning time will become longer. And also I will ask how many megapixel for your camera. And because camera is very important.
Yeah.
If you get the higher megapixel camera, you can get bigger FOV. Also, you can get clear image. So that is also very important.
So ask about resolution, ask about megapixels.
Megapixels.
The higher the resolution, the higher the megapixel count, the better.
Yes.
In general. Any other factors you would be concerned about?
Also, I will ask how accurate is your XY table? Okay, how is your gauge NR? That is the one when I was engineer, I will ask my vendor to test, to try it. I want to see the number and see how good your machine is.
Excellent.
Yep.
Well, David Chiu, this is a short episode today. Thank you for being here for this short episode.
Nice
I wish you all the success in the world with your... Is this a new machine launch?
Yes. That's
First time here at the show?
Yes.
Well,
it's our new machine.
Good luck with that.
21 megapixel.
21?
Yes.
Wow.
That's our newest machine and the high speed.
So you have resolution and speed.
Yes.
And
that's why I want you guys to take a look for our machine in TRI booth.
Excellent. Well, David Chiu, sales manager, Test Research
Test
Incorporated.
Research.
I'll get the name right eventually. It's on the third try.
No problem.
Test Research Incorporated, thank you for being my guest. I appreciate it.
Thank you, Mike.
All right,
Thank
take
you.
care. For this segment, I'm here with Mike Dolan with South-Tek Systems. What's your position at South-Tek Systems, Mike?
I'm the director of sales and marketing.
Okay, you're the guy.
I'm allegedly the guy, right?
Allegedly the guy. All the engineers are going, I hope he doesn't say he could do this or that, because now we have to make it happen.
They keep me in line. They keep me in line.
Let's talk about nitrogen.
Great.
What do you say?
Let's do that.
You know anything about it?
A little bit.
Thing or two?
More than I knew in high school, put it that way.
There you go. Fortunately, I am aware that nitrogen's used in like reflow ovens and inerting atmospheres and things like that. Before we get into what you guys do, explain to me and my audience, what is nitrogen used for? Why is it being used? What types of applications is it used for within the electronic assembly space?
Great question. So nitrogen is used as a process gas. And specifically for the electronics industry, nitrogen at a high purity, so 99.9% or even higher as a process gas, allows for the even soldering when the circuit boards are going through an oven.
Is that because without nitrogen, things oxidize faster? And
you get oxidation, and the inertness of the nitrogen allows for almost a vacuum-like field without a vacuum.
So it lowers the surface tension, so things reflow a little better. I was talking to someone yesterday that monitors nitrogen levels.
Yep.
They don't sell nitrogen, right? So you don't have to kill them, right?
No worries.
They're no competitor, but they monitor nitrogen levels. And he was saying that there's a such thing as too much, too little. They kind of need the Goldilocks principle there. So too little, well, you might get oxidation and cracking and whatever.
Right.
Too much, I don't know, other bad things.
So with too much nitrogen, if it's flooded too much, you'll get unevenness. So there is a balance when they want to go. And that comes down to a term that you'll hear a lot, what flow is coming into the oven. And as long as the flow is measured correctly, that's when you get the best result ultimately of using the inert nitrogen.
And I can understand conceptually that purity levels would seem to be important.
They are.
I don't have a point of reference. Is 99.9 or is 99.999 good, and why it's so much better? What are we concerned about specifically with purity levels of nitrogen?
Great question. So you wouldn't think that the tolerance would be this tight, but in the electronics industry, obviously, you want those tightest tolerances. So we consider high purity nitrogen 99.99, what we call 4 nines, all the way up to 99.999, which is 5 nines. And what that means ultimately is there's an absence of oxygen, trace oxygen, or other trace inert gases. So the more pure your nitrogen can be, the benefits of using nitrogen are actually multiplied when it comes to, I talked about that consistency of the solder on the circuit boards.
Besides being in reflow ovens, is it used in any other part of the assembly process that you're aware of?
Mostly in the reflow ovens.
Mostly in the reflow ovens. And wave solder machines too, right?
Exactly.
I remember back in the early days of my career, there were wave solder machines, and when No Clean first came out, all of a sudden they started using nitrogen. Because No Clean in the early days was really hard to solder to.
Exactly.
Right? The flux was not that active.
Right.
And therefore, any little contamination on the assembly, any little bit of corrosiveness on the assembly would wreak reflow havocs. And nitrogen was like a tool in the pocket.
It's an incredible gas to use in a field because it's inert. Your chances of any contaminant being in there goes away. And that's the benefit of nitrogen.
So as I understand it, there are two ways one can implement nitrogen. They can have these tanks outside their building, and the company comes in a big truck and fills them up once in a while.
Right.
Or maybe smaller bottles that can attach directly to a machine.
Cylinders.
Cylinders like that.
Right.
And you can generate it yourself.
Correct.
So where would the threshold be between someone who is more optimized just buying bottles,
right,
or maybe having a large tank filled outside their factory,
right,
versus making it themselves, point of use type thing?
So I'm going to weave this through the lens of cost effectiveness.
Yeah.
If you're not using a lot or you're not consuming a lot, then nitrogen generation on premise may not be cost effective because of the equipment. But most people that are in a production space or a manufacturing space definitely consume enough nitrogen where the on-premise making of it versus the delivery of it is going to be cost effective for them. And I'll give you an example. If in your process weekly, you're going through maybe 1 or 2 cylinders of nitrogen, that's probably cost effective and that's plenty. Anything beyond that, the math would indicate that you're going to save money by making nitrogen yourself on premise.
And when they're made on premise, when nitrogen is made on premise, is it being made to charge bottles that are brought to a machine, or is it being connected directly to a point of use?
Great question. Can be both. So you could be refilling cylinders in a high pressure application or in a low pressure application, point of use into a particular piece of equipment, whether it's an oven or other pieces like that.
So if you have 5 SMT lines with 5 reflow ovens,
right,
one may not, you would love it, but one may not want to get 5 nitrogen generators, right?
Right.
So in that case, you could use one as a distribution to these machines,
exactly.
Bottles or going direct to the machine.
Exactly. So you can make nitrogen with the generator size to certain levels of volume and quantity that would allow you to have one big storage tank. You mentioned that earlier, but instead of the storage tank being refilled by delivery, you're actually refilling it with your own manufactured nitrogen, and that can feed the various lines.
So if I buy nitrogen from a nitrogen supplier, that's all they do. They just make nitrogen, put it on a truck, and deliver it to my premise. I just have an assumption that if I'm paying for 4 nines, I'm getting 4 nines.
Right.
Because that's all they do.
Correct.
They have one job.
Yep.
If I'm making nitrogen, if I have a machine that can make nitrogen,
yep,
do I have the same level of confidence that I'm getting what you say I'm going to be getting?
Correct.
And how do I know that?
So within the systems themselves, there are various tolerance checks and then obviously electronic monitoring equipment now. Within our PLC, for example, you'll actually see a constant readout of what your purity is. We have alarms and checks so that you know, even if it's making nitrogen after that you're getting exactly the nitrogen purity that we committed to, guaranteed, and dialed you into.
Final question. I'm searching for a nitrogen generator. Don't get excited. This is only hypothetical.
Great sales call.
I'm searching for a nitrogen generation system. I've determined that it's going to be cheaper for me to generate it on site than to buy bottles. I don't know much about it. What questions should I ask potential suppliers of such equipment that would allow me to vet the supplier and the technology that the supplier is proposing to provide?
Right. So the question you'd want to ask any potential supplier of a nitrogen generator is, what's the technology? That's the first question. That's going to be either PSA or membrane. For your audience, PSA is always the way to go. It's more efficient and there's a higher purity level. Second, the equipment. What is your service life? What is the preventative maintenance program? This is industrial machinery. If you want this equipment to do the best for you, you want to take care of it. So you want to make sure that manufacturer of this equipment has a great service program that they can sell you so that you're not having breakdowns in the equipment or missing parts during the life cycle of the unit.
Sure. System goes down, you're not reflowing boards.
Exactly.
You're not reflowing boards.
You're stopped.
Someone's not getting their Ford truck or whatever, right? So, yeah. So it's a big...
In our business, what we never want to hear is you shut down a line.
Yeah. Yeah. Many things you don't want to hear. That's kind of top of the list in your world.
You got it.
Well, thank you so much for being my guest on this show.
Thank you for having me.
I really appreciate your knowledge in that field. I'm not real up to speed in it, so it's interesting for me to learn. So thank you very much.
Thank
you.
you. Nice to see you.
Take care.
Bye-bye.
My guest on this segment is Dalton Dodge. He's with Brooks Automation. Welcome, Dalton. Thanks for being here.
Thank you very much. Thank you for having me.
We are going to talk. I found out about you about 86 seconds ago. And so I don't know much about the products you make, but from what you told me in the last 86 seconds, it sounds very interesting. You make robots for automated test islands. Okay, let's back up a little bit. Robot part I can get, and we'll get into that. Tell me what automated test islands are, what type of application within the electronic assembly space, testing obviously, that are they used for, and then let's get into how your robots integrate within that space.
Sounds great. Yeah, so we have been selling collaborative robots or innovating collaborative robots for many, many years. We are an industry leader in laboratory automation. And in that industry, the application is very much similar to what you'll see at the digital test booth, which is we are accessing high-density storage racks of samples, in this case, panels or PCBs. And the robot is sitting there all day long, accessing those, loading and unloading automated FCT, ICT, burn-in, you name it. This would be a back-end application after the entire SMT process. And what we're really trying to focus on and showcase is flexible automation that's affordable and doesn't require end users to really have to develop a very expensive, crazy production line. It should be very accessible, and they should be able to adapt their existing production lines to something like a collaborative robot.
So these tests, you mentioned ICT, I think he said FCT, these types of tests, are they historically performed just by human hands? And you're not changing the test protocol, you're making it more efficient.
That's right. In parts like North America, Europe, of course, this has been done, and in Asia heavily. I think COVID-19 exposed the supply chain very much, and now you have companies wanting to future-proof. You have a lot of companies looking at wanting to do lights-out manufacturing, 3 shifts a day. Labor rates are going up, I think, universally everywhere, and now people are really looking at automation more than ever. If you don't have the capital to justify a very, very expensive inline system, I think the gap fill, and we believe the gap fill could be something like a collaborative robot, which is, again, very flexible, much more affordable. People, I think, understand robots to a degree, especially when they're easy to use.
More now than ever, yeah.
More now than ever. The education's out there. And, take a typical production floor. You're going to have, 2 to 3 shifts, many, many banks of testers. Someone is, ultimately paying someone to sit there, load and unload these testers all day long. While that's great, completely understand, there's a lot of room for human error. Quality might suffer at some point, especially when you have, guys working longer than 8-hour days all the time. And so the robot serves as that step in to perform that task.
So on the subject of reducing human error, I can understand the labor component.
Sure.
Yeah, we take a person out of it. Obviously, it's going to be a little cheaper once some ROI on the investment. From a reliability standpoint or a consistency standpoint, what types of errors do humans make typically? I know it varies on the type of testing, but in general, do humans make that robots tend not to make?
Sure. One off the top of my head could be, someone could be very tired or working extended hours. You're using your eyes to do very basic, say, part presence, part absence type of inspections, nothing super heavy. But there's room for error there. Someone could mistakenly put a pass board into a failed magazine, or more importantly, a failed board or a failed assembly into a pass batch. Down the line, someone's going to encounter that. There will be a bottleneck somewhere, and that can cascade anywhere on the line. Those are just two basic examples, of course.
So if I said, okay, Dalton, I'm sold. I'm going to buy a system, integrate it with my testers. Do I integrate it with my testers? Does Dalton say to me, okay, tell me what kind of testers you have, what type of parts you're testing, tell me more about your environment, we'll pre-program everything. Does it already come out of a box knowing who it's playing with?
Sure, yeah, there's a little bit of a story to tell there. So Brooks, we are focused on innovating the robots and manufacturing the robots. And the way we try to get our robots onto production floors and help people out, we want to identify very competent systems integrators or value-add distributors. From the robot's perspective, it's agnostic to tester A, tester B, software A, software B. We look for people that understand robots, understand test excellency, understand the customer. They see the robot as a value add, and they're going to tie the robot into an existing line, make it communicate to the tester, package all that together mechanically, and deploy that into a work cell. So from the robot, doesn't care if it's tester from vendor A or vendor B. It just wants to sit there literally all day and load and unload the tester.
Interesting. And finally, last question. If I was in the market to buy something like this, and I didn't know much about you, I don't have to actually go too far off the reservation to know that's true, because I don't know much about Brooks Automation, but I don't know much about the whole industry. What types of questions should I be asking to be an intelligent discerner of the different options that are out there for automating tests?
I think a very common one, actually, and this people might not even really think about this because it's just out there all the time, but there's angle testers versus flat testers. Some robot manufacturers will only offer, a variant that can do 6 axes. Some have 4 axes. So literally how the test cell is set up mechanically is something to consider. With collaborative robots, more importantly, people would need to understand that there will always be not a fight, but you have to think about throughput versus accuracy versus flexibility versus reliability. If you want things to rip and really go fast and maintain throughput, robot could probably do the job, but you'd also probably consider an inline system. And then, the faster the robot goes, typically the more unsafe it is. And if it's really an unsafe system, now you get into caging the system and really blocking off your operators from accessing it. It's not really collaborative. It's not flexible. So safety should be.
There's a happy medium somewhere.
That's right.
Right.
Yeah.
And your company could help guide. I'm assuming it's probably important for the customer to ask the right questions, but it's equally important, maybe even more, for you to ask the right questions. Right.
My background is in applications, and I believe applications engineers should be masters of asking those type of questions to the customers, helping the customer define their specs so that they're very well informed and understand what they're getting at the end of the day.
Excellent.
Yeah.
Well, Dalton, thank you so much for being my guest today. Thanks for spending the last few minutes educating me. I feel a little bit smarter today. So, if I happen to fall into a conversation about automation of test systems, I can at least carry a 5-minute conversation. So thank you very much.
Thank you for having me.
I appreciate you being here.
Thank you.
Welcome back to our final segment of the Reliability Matters podcast. And I have intentionally saved the best for last. My friend and colleague, Michelle Ogihara, thank you so much for being here today.
Oh, it's always such a great pleasure to be with you, Mike.
And, I'm so glad that we are using these 4K cameras because they're going to just capture all the color that you are emanating right now. So thank you.
Well, believe it or not, it's not just a costume. We are celebrating Seka Machinery's 30th anniversary.
Congratulations.
Thank you so much. And so tonight we'll have a special dinner at a Hawaiian fusion restaurant. Nice. And so I thought I would just play up the theme and just early on put on my Hawaiian dress.
You don't do things halfway, Michelle. You go all in. I love that about you. Tell me a little bit about Seka Machinery. Your distributors for a number of different products, and in the U.S. The products are Japanese-made, I think, largely. Is that correct?
Yes.
And what types of products do you provide your customers here in the States?
We provide the top-tier brands from Japan, as you mentioned previously, and that would include the Tamura reflow ovens, the Sayaka PCB routers, Hioki flying probe testers, Sawa ultrasonic cleaners, McDry dry storage cabinets, Kyowa strain gauges, South-Tek selective soldering, Malcolm process control devices, Unitech PCB cleaners, and the list goes on and on.
Yeah.
Actually, a lot of our principals are here because they're celebrating our 30th anniversary celebration. And so we're very appreciative to have them come and support our very special day and event.
Excellent. Well, a lot of your products that you were mentioning, some of which I don't know what they do, some of which I caught on to. The ones that I caught on to definitely have a leg in reliability, providing a more reliable end product. So I'm thinking of your dry boxes, for example. And, people are storing bare boards in there, among other things maybe, and to prevent moisture migration into the part, which in my world prevents electrochemical migration, cause failures, and conductive anodic filament, and all this stuff. So those dry boxes play that role. Ultrasonic cleaning of stencils plays that role because obviously you need clean apertures in order to get good prints, because everything starts with the print. So the stuff that you guys provide, the products that you guys provide, definitely add to the reliability of a customer's end-use product.
Oh, absolutely.
In many ways.
Thank you.
Now, let's talk about some fun stuff. Let's talk about, you and I share one thing in common, many things in common, but this one thing is our passion for SMTA, Surface Mount Technology Association. And you are one of the biggest brand ambassadors SMTA has. You sing its praises, sometimes quite literally, sing its praises quite regularly. Let's talk about young people entering our industry. They're coming out of college. They're ready to go. They don't know anyone. What advice would you give them relative to joining an association, and like SMTA or others? And what advantages does being part of that type of community provide. How has it helped you, and how do you think it would help younger people as they enter the industry?
Well, I think you and I, we consider ourselves forever youthful, forever young at heart. And so that's why it's easy for us to embrace the up and coming, the young professionals. And I think that we can all always empathize and know that perhaps there's some insecurity coming in, or also open-mindedness and excitement to see what's available, what's new. And if we always have that type of open-minded, nature and inquisitive nature, and also, but from the other perspective, I think you and I also see the capabilities, and also we treat our youth with respect and know that they can teach us a thing or two. So if they come with that attitude of wanting to contribute to the association, as well as to learn from their seniors and receive mentoring, then I think it's always a win-win situation.
Yeah. And also I'll add to that, as older, more seasoned professionals are leaving the industry, they're retiring. The U.S. is seeing the greatest retirement in its history. The baby boomers are all coming of age, and they're all retiring. And we're having, I think I read a stat that 8,000 people a day are retiring. And between now and 2035, 8 to 10,000 people every day will retire. That's huge, right? Because we were all born after World War II, right?
Yes,
got busy after World War II.
One of the biggest and so-called greatest generations. So
yes, so that means a lot of subject matter experts are leaving and not being replaced with other subject matter experts. So there's this void, and I think that's where trade associations like SMTA and others really fill a role, because of knowledge bases like SMTA
we can pass on
training sessions at SMTA,
all of that vast experience and knowledge, as you say.
Exactly.
But we can also embrace and see what the future holds, and we have to be open to that. And we have to be open-minded to also embrace the new ways which these future technologies and come up.
Yeah.
And I think it's really a key important fact. And that's why the young professionals in SMTA, in an IPC, really bring that new excitement to our association. We have to be willing to listen and also adopt a lot of what they have to say into this industry.
Yeah. I'm convinced that whenever I start a conversation with the phrase "kids these days," I've now officially become my father. Because all the older generations thought they were doomed with the new generation. My generation was supposed to doom the world. Your generation is supposed to doom the world. It didn't. This new generation, we all go, kids these days, right? Heads are always in phones, whatever. But they will do it better than we ever did at some point. They'll just do it differently. And I think our role as the guardians at the retirement gate is to help guide this young generation and then get out of their way and let them soar, right?
Absolutely.
I think associations can help do that, particularly with people like you as a ambassador for SMTA. So thanks for doing that. Thanks for all your involvement with the association. Thanks for being here. Thanks for being my guest. And aloha.
Thank you for having me.
And aloha.
Mahalo.
Good luck tonight. Mahalo. Yes. Well, that's another episode. Thanks for listening to or watching the Reliability Matters podcast. Don't miss an episode. Subscribe to Reliability Matters on your favorite podcast app. If you're watching this podcast on the Reliability Matters YouTube channel, be sure to click the like, subscribe, and bell icons to be notified when new episodes are released. We release new episodes on the second and fourth Tuesday of every month. A special thanks to Circuit Assembly Magazine's PCB Chat at pcbchat.com and Ascendo Reliability at reliability.fm for syndicating the show. Thanks also for your questions and episode suggestions. Please keep them coming. I love to hear from you. Send comments or episode suggestions to Mike at mikeconrad.com. That's Conrad spelled with a K. Once again, thanks for listening or watching. Stay safe, stay healthy, stay happy, and perhaps most importantly, keep doing it right. I'll see you again in 2 weeks.
Thanks for listening to the Reliability Matters podcast. Join us on the second and fourth Tuesday of each month for new episodes of Reliability Matters.